Hey, welcome to this two-part video on solving rational equations. Part 1, we will be working with rational expressions that are equated to constant values like 0 or 2 or 3 and so on. Part 2, we will have two rational expressions on opposite sides, and this will be a little bit more challenging for us to solve it. So let's begin with part 1, where we have on the screen a rational equation, which is simply a division of two polynomials, and that's the left side, and the right hand side, this is equal to 0. So the first thing you do, the restrictions. So you look at the domain. And you see x squared plus x minus 2, and you let it equal to 0. And once you find what makes it 0, you will eliminate those numbers. So you would restrict those values. So make it equal to 0, the denominator. Solve it. This is a quadratic equation solved by factoring. So this is my restricted values, -1 and -2 and +1. In case you get a solution that is equal to -2 or +1, you must reject, because this is not allowed. So let's go back to our question. A rational equation should remind you of a rational number, because you have a division, you have a numerator, you have the denominator, right? You have top parts, the bottom parts. When you divide it and the answer is 0, this is only possible when the numerator is 0. So that simply means if I divide two numbers and the result is 0, so the top number is always 0. So when you remember that, you always will be able to solve successfully any rational equation. So this is why we say 2x squared plus x minus 1 is equal to 0. And we will solve it by factoring. So the product is 2 times -1, and the sum is equal to +1. So let's solve that by factoring. Let's see what that will give us. Okay. Once we figured out the numbers involved here are 2 and -1, you simply expand this trinomial into polynomial with 4 terms. Then you will group this first two. You group them in any order you like. Common factor here, quickly, 2x squared plus 2x. Common factor is 2x, so take it out, in goes x plus 1. And from the second group of 2, take out -1, right here. So you have another factor, x plus 1 in brackets. And now x plus 1 and x plus 1 is a common factor. So take it out. X plus 1 goes out as a common factor, and you put 2x from that and -1 from this part, and you have this equation in factored form, which simply means x is equal to -1 or x is equal to 1/2. Check for against your restricted values. Everything seems to be fine. This is the solution. So one way by factoring. The second possibility you have by using quadratic formula. Identify quickly coefficients. What is A? 2. B is 1. C is -1. Boom, you have it. Now, quadratic formula. The quadratic formula that we need to recall looks like so. -b, the discriminant, so plus or minus b squared minus 4ac, everything is divided by 2a. So the next step would be natural to plug in the values of b, a, and c into the quadratic formula. And then you start solving it. So inside of that radical, there's a value of 9, so this is why you will have -1 plus or minus 3, divide everything by 4. And two possibilities are the same as if you were to solve it by factoring. So it doesn't matter which way you solve it. Just be aware of that factoring will not always be possible. So quadratic formula, it's much better choice. And go back to this original equation. Remember the following. When the quotient is equal to 0, that means the top number is to be 0. That's the key here. So if the numerator is set equal to 0, you solve it. Whether this is quadratic or linear or cubic or greater degree, you can only solve it by factoring. For cubic quartic, quadratic, you can solve it by quadratic formula or factoring. Linear, simply you solve it by rearranging it. So let's move to the next page where we will now work with the same ratio, but this time instead of being equal to 0, it is equal to 2. Same restrictions, -2 and 1. So recall, you have here a little call out for proportion. So one of the property of the proportion is that you can cross multiply. You can say 2x squared plus x minus 1, this will be multiplied by 1, and the next time you will multiply the denominator times 2, and this method allows you to eliminate fractions, because not too many of us do like fractions, don't we? Okay, so understanding this process, now you cross multiply. You cross multiply, and you have, this is the first step if you were to do it. Right here, you cross multiply, and you have to multiply by 2 each term inside, So this is why you have the left side is unchanged, the right hand side has 2x squared plus 2x minus 4. So 2x squared, because if it's the same term on both sides, get cancelled. Or recall the rule that you can subtract from both sides 2x squared. So now the next step is to find solution to linear equation. Boom. X minus 1 on the left, 2x minus 4 right here. Combine terms with x on one side, numbers on the opposite side. Simplify, solve it, and you have it. You may say, well, this is maybe very tricky because it's too easy. Well, let's do this same question now and equate to a different constant value. So you will not eliminate the second degree term. However, that's a possibility. If you do have that options, you eliminate. You always check the solution against the restrictions. 3, nothing in common with these two values, therefore it works. So let's modify this question. Now we'll say this is equal to 3 instead of 2. Restrictions are the same, numerator, denominator is still the same. Cross multiply. Remember the proportion? You would see this as over 1. You will combine these two together and that part with this together. So let's do it. Boom. Done. Times 3. Distributive property. You nicely do multiply everything by 3. This is why you have that. And now by comparison, you see that no terms is to be cancelled. Okay. So rearrange. Combine everything together and make a nice quadratic equation. Beautiful quadratic equation by combining x squared, x terms, constant values. You have -5, you have negative. Okay. you would have 5, you would have negative 2, this is what you would have, and you would have negative x squared. It is nicer situation when we have the first leading coefficient positive, so the rule allows me to multiply by negative 1 and get positive, positive, and negative. Okay, but if you didn't do that, same thing. The solutions would be the same. So quadratic equation, let's solve it by using quadratic formula. Okay, so quadratic formula, we all know. If we don't, this is right here for you. So negative b, a and c. So what is a? A is 1, b is 2, c is negative 5. So this is why you have it, the statement right here in that form. The next step is to further simplify. And the square root now is 24. As you calculate that, you will have 4, take away 4 times 1 times negative 5. So your goal is not to use a calculator and then get some decimal numbers. You want to show it exact. By just taking a closer look at square root 24, 24 can be split into a product, 4 times 6. 4, as a perfect square number, goes outside, so you have 2 times radical 6. So simplifying it, very important. So in the next step, you see why you have negative 2 minus 2 root 6, or negative 2 plus 2 root 6. Everything is divided by 2, and now we can divide each root separately by 2. So further we can simplify this. Isn't that lovely? So this is why the root is negative 1 minus square root 6, negative 1 plus square root 6. These two roots are the solution to that equation. These two roots are not equal to a restricted value, therefore they well defined, we accept them, we are excited. So this is how we solve this rational equation. So far we did equal to 0, equal to a constant number. You either use the fact that when 0 is shown, that means the top number must be equal to 0 since you divided. If the rational expression is equal to a constant number, you cross multiply, simplify it, and solve it. So I hope you have enjoyed this video. Please post any questions or any comments right below, and I see you for part 2 when we'll do a little bit more challenging question. Thank you. Bye for now.